We will now look at how to compute the derivative of a constant c times our function f of x. Let's start with an example. Say our function f of x equals 2x squared, and we want to compute its derivative. Well, we already have the tools to do this by writing 2x squared as x squared plus x squared. Then we can break the derivative up as the derivative of x squared plus the derivative of x squared using what we found in the last video. Since the derivative of x squared is 2x, this becomes 2x plus 2x, which is 4x. So we have that the derivative of 2x squared is 4x. What if we change our function to 3x squared and want to compute its derivative? Well, we can write 3x squared as x squared plus x squared plus x squared and break it up as the derivative of x squared plus the derivative of x squared plus the derivative of x squared, with each one of these being 2x, for a total of 6x. So the derivative of 3x squared is 6x. Let's now change our function to f of x equals 162x squared, and we want to compute its derivative. Using the technique we just looked at, we can write this as the derivative of x squared plus x squared plus x squared, and so on 162 times. But we don't really want to do that. So let's go back to our definition of the derivative. F prime of x is the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. If we compute the derivative of a constant c times f of x, we simply replace f with c times f. So in our definition of the derivative, we get the limit as delta x goes to 0 of c times f of x plus delta x minus c times f of x all over delta x. But we can factor c out from the top to get c times f of x plus delta x minus f of x all over delta x. But pulling c off of our fraction, we see that we have c times the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. But this is simply c times the derivative of f. So we have that the derivative of a constant times f of x is that constant times the derivative of f of x. Let's go back to our example of f of x equals 162x squared. In computing its derivative, we now know that we can pull out the 162 to rewrite this as 162 times the derivative of x squared. Now, we know the derivative of x squared is 2x, so this is 162 times 2x, which can be simplified as 324x. So the derivative of 162x squared is 324x. For another example, let's compute the derivative of 32x to the 12th. What we just found was that we can pull the 32 out and have 32 times the derivative of x to the 12th. Using what we found about the derivative of powers of x, we know the derivative of x to the 12th is 12x to the 11th. So we have 32 times 12x to the 11th. Multiplying 32 times 12, we can simplify this as 384 times x to the 11th. So the derivative of 32x to the 12th is 384x to the 11th.